Good afternoon, ladies and gentlemen. Welcome to this pair distinguished lecture series. My name is Qing Chen. I'm the director of the PolyU Academy of Interdisciplinary Research. And I'd like to welcome all of you, especially those online who you probably can hear me and also watch it through videos. Usually we have more than 15,000 audience online. So now I'd like to introduce our distinguished speaker today. That's Professor Daniel Kammen, who is a Bloomberg Distinguished Professor of Energy and Climate Justice at Johns Hopkins University in the United States. So Professor Kammen is an international recognized scholar in renewable energy and a former senior government official. His contribution to the energy field are exceptionally wide-ranging, spanning both scientific and policy domains. His work encompasses the advance of energy innovation, the decarbonization of energy systems worldwide, the expansion of energy access in underserved regions, and the development of a pathway toward a truly equitable and sustainable global future. So most recently, Professor Kammen serves as a senior advisor for energy and innovation at the U.S. Agency for International Development. Prior to that, he was appointed science envoy for the U.S. Department of the State during the Obama administration. So Professor Kammen's research is distinguished by his interdisciplinary approach, integrating scientific, technological, and social dimensions to address energy challenges. His work combines advanced modeling of energy systems with practical implementation. His research group has developed a suite of scalable, equitable energy solutions to support sustainable development. For example, he developed the open source power system planning model called SWITCH, which is used in US and China as well. In addition, his team has designed many grid systems for rural communities, including those in Africa and the southwestern United States, providing low-cost, low-carbon electricity to remote and underserved populations. So Professor Kammen is a member of the U.S. National Academy of Sciences and the American Academy of Arts and Sciences, which are truly the highest honor in the United States. In 2007, the Intergovernmental Panel on Climate Change, called IPCC, for which he has served as a contributor and contributing and coordinating lead author since 1999, was awarded the Nobel Peace Prize. So you probably, if you are senior enough like me, we know at that time, that was really a big event, the first time give the award to a big organization. So the IPCC is the United Nations leading scientific body on climate change, which made a tremendous influence today. So without further ado, ladies and gentlemen, please join me in welcoming Professor Daniel Kammen.
So it's my distinct pleasure and honor to be here at PolyU today. I want to thank everyone in the audience, my hosts, colleagues, both the audience here and online. And I hope that what I'll try to cover today will be a mixture of scientific and policy innovation, but also a broader discussion about a unique opportunity that we have to collaborate, in particular around an investment that Johns Hopkins and partners are making around the world. And it's why I left Berkeley after 26 wonderful years there to be based not only at Johns Hopkins at its campus in Baltimore, Maryland, and in Washington, D.C., but also hopefully opening a new campus in Africa that will come up at the end of the talk. And it's an area where I think that the type of innovation, the partnerships we need, and in particular, the positive interaction of the US and China and Hong Kong will be critical to building a safe and just climate future. And I know that the United States is unfortunately taking a slight break from sanity right now under our current regime. But I go back to what happened during the Cold War when physicists, which is my community, in the United States and the Soviet Union worked together so that when the time was right, governments could cooperate. And I hope that that will be one of the messages that comes out of today's comments. In fact, the partner that I've had the longest in China is, in my view, probably the smartest person working on energy and climate policy, and it is former Chinese Minister of Science and Technology Wang Geng, who used to say over and over again, governments or countries must cooperate so that companies can compete to really move us ahead. And as you'll hear over and over again, in my opinion, it's impossible for the world to get to a safe climate solution without the G2 of energy, the G2 of pollution, the G2 of innovation. That's the US and China working together. So I hope you'll see that again and again in the talk. And so without further ado, let me start. But those will hopefully be the messages that really come through. So I'll try to do this through a couple examples. And as like any professor, you overfill the time. So I'm sure I'll go quicker and quicker through the examples. But I want to look a little bit at the energy innovation that's happened in the part of the United States that is still thoughtful and sane, and that's the West. And I'll talk a little bit about the emerging innovation ecosystems in China and in Africa, because these are really critical to thinking about how we can move forward in this process. I'm hoping that this talk will be a little more than an advertisement. It'll be some substance, but really an opportunity to find ways to work together in future. So I list here my laboratory, the URL for my research group, Renew, the Renewable Energy and Equity Worldwide Laboratory at Johns Hopkins. And also for those of you who use Blue Sky or Twitter, X, whatever it's called, which is questionable right now, that these are some of the ways to engage, to follow some of the work we do. And we have a podcast that we're in season 2. Claire Broido was my first student when I was a postdoctoral fellow at Harvard. She is now an energy entrepreneur based in Baltimore, Maryland. We hope that you'll be interested to engage with the podcast to see some of the things we're working on. So that's kind of the coordinates. But I want to spend 2 minutes because almost every student asks me, how did you go from studying cosmology and astrophysics to whatever it is that we do now, sustainability studies? And I don't think I can give any coherent answer. There was no organized path I took, but the partners I developed along the way really defined how our laboratory works. And so these are some of the civil society or NGO organizations that we've worked with. Blue Energy is a campesino, a community organization in eastern Nicaragua. The Human Needs Project is a women's empowerment group in the largest slum in Kenya, Kibera. The Blue Climate Initiative, I'll come back to at the end. That's an effort to work on sustainable marine solutions. Blue Climate is based at Berkeley, but in particular, it's based in French Polynesia. And as you'll hear in a bit, we're hoping to do something like a mild version of your state key laboratory for marine solutions based in Kenya. Native Renewables works with the First Peoples in North America, Native Americans or First Peoples, depending on Canada or US. All of these are groups. The Virunga National Park, the oldest national park in Africa. All of these are partners that we work with in various ways to make sure civil society has a strong voice not just to be a subject, but to be a generator of innovations in technology. And we heard in this very kind introduction, one of the tools our laboratory has built is this model called SWITCH. SWITCH stands roughly for solar and wind integrated with transmission and conventional energy. It's a loose acronym, but it's an open access, open source modeling platform to plan the grid. For electrical engineers, it's called the capacity expansion model. That won't be important, but it's a model to think about how we build the grid. And all of the countries here, including China, have in one way or another become formal partners, not just places where we gather some data and write papers. But in each case, there's a government office or a government agency in each of the countries here that is a formal recipient of the model. We only build this model in countries where we have enough energy access, enough data access. And as you know, in many countries around the world, data on the state of the grid, power plants, energy prices is quite sensitive. In some places, it's more sensitive than others. But all of these have signed some kind of agreement with my laboratory and also one or more institutions in their country, whether it's a university or whether it's a nonprofit group, so that we build these models in real partnership. And again, they're open access. So the data can be sensitive, the modeling tools are open. And all of these in different ways, our work in Kenya, in Tanzania, in the Democratic Republic of Congo, in Morocco, in Colombia and Mexico, in the nation state and more nation than state today of California. Maybe later on we can be a little more part of the US if the US improves itself. All of these are partners, and really what this has generated opportunity is for us to create companies that generate a wide range of products. Nline makes smart sensors for the grid. Alpha Ring is our fusion company. Grid Alternatives does energy justice. I'll mention Pear City later on. It's a Shenzhen-based company. I'll come back to these, but each of these have been opportunities to try to spin out some of the products that we're doing to work in different ways. And we work with a variety of the academic societies that support innovation and partnership and student exchange. You see those at the bottom. So I won't do a full lecture on climate change. That would take far more time, but I don't think it's responsible, especially given where the US is in withdrawing from institutions and being an impediment to world peace, an impediment to partnership today. Hopefully that will end soon, but just to highlight the story that we are somewhere in the top blue band, meaning that if every country did what it said around climate, we would limit warming to an unacceptable level, but to a level where global temperatures would go up perhaps 3 degrees. Some people, myself included, thought that before the re-election of Mr. Trump, that the 1.5 degree pathway, the green line, was possible. I currently do not think that's possible anymore. The amount of warming we can do to get there is essentially zero. I think we've crossed the 1.5 degree threshold irrevocably. But you'll notice that whether you're a climate scientist or not, that this is a dramatic reduction, not only to zero, but then going negative. I will not talk about the negative technologies, absorbing carbon, in this talk, but ultimately we'll have to get there as well. All of these other pathways in the middle are ones that were within reach. And again, I think that the recent US actions may have put almost all of them out of reach. I am hopeful that with the dramatic improvements of energy systems, the massive manufacturing and installation of clean energy in Asia, recently, probably all of them in this room know that China has essentially equaled the entire rest of the world's clean energy, while the US is invading oil-rich countries. 2 totally different pathways to think about the future. One maybe thinking about the past. But this is the path we need to be on. And just to highlight it, again, I've been part of the IPCC for many decades. And essentially the difference between the 1.5 degree pathway that we, the IPCC, part of the UN recommended for the Paris Climate Conference. That was 9 years ago. At 1.5 degrees versus 2 degrees, the best we can probably do now, there's some debate, but probably 2 degrees itself would be a huge stretch. More or less all of the damages, coral reef bleachings, extreme storms, famines, lack of food, basically things become twice as bad if we go from the 1.5 degree to the 2 degree target. And just to show you how badly and how fast things are going, if we look at New York City under a clear May day, 2 days later, it's under this orange cloud due to fires in Canada. And just to highlight, those of you who have seen a movie I truly enjoy, Blade Runner 2049, Hollywood 4 years ago envisioned mid-century not as bad as we saw in New York City 3 years ago. So reality has overtaken even science fiction in terms of the damages, the health, the other features in the story. Now, if that story wasn't depressing enough, the second part of the story is that if the only thing we were worried about, and I say only in quotes, if the only thing we were worried about was how warm it's gotten, that'd be one thing. But that's not the full story. In the same time that we've been examining and different countries doing their parts in different ways, I'll talk about California in a bit, but China's net zero target is 2060. There are some people who think maybe it can get there by 2050. California has set a 2045 target. But that's part of the story. The other part is that the United Nations has designed and developed 17 different sustainable development indicators, all of which are very straightforward goals for 2030. Food availability for everybody. Clean energy and clean cooking available for everyone by 2030. That's SDG, Sustainable Development Goal number 7. Equal access to education for boys and girls. Healthy water systems. None of these are debatable. All of these are goals for 2030. And for each of these, the most recent assessment is if you see red, it means we're making negative progress. So we are losing ground on the things that people around the planet will care about. Yes, the temperature is important, and we can't air condition the world, but ultimately food availability, all of these more detailed things are what we really see, and we are making negative progress on many of them. So as hard as you think climate change is, in my opinion, as a physicist, not an economist, we need to strongly engage on these other themes because we're not making enough progress as we go. We need to add a constraint to make the problem more soluble, which economists don't think that way, physicists do. We need to broaden the community engaged in this area, and that's why I'll come back at the end to the many opportunities of investing in, for example, Africa as a partnership that we might bring out of the process. Very briefly, the California story is worth highlighting. And I know that many people used to view California as having this exceptional opportunity, somehow great weather, infinite money, it can do anything, but that's not true. California's initial climate goal was to provide 20% of our electricity from renewable energy, sustainable energy by 2010. And I'll define renewable and sustainable in a second. It's not the same everywhere in the world. California's goal for 2010, we achieved it in 2013, 3 years late. Whoops. No, it's okay. I can just, there we go. That was a failure. California's goal for 2020 was to be 1/3 powered by renewable energy. That goal we achieved in 2017. So from missing the 2010 goal to meeting 2020 3 years early. And I highlight that because one of the differences in energy infrastructure policy around the world is how you use goals. And I would argue that each method is imperfect, but each one needs the other. And very broadly and very crudely, the Chinese approach, and this is a very oversimplified, high-level statement, overall, the Chinese approach is to do high quality analysis and set an achievable goal and achieve it. And that's excellent. But it also, in some cases, lacks vision. I don't mean that as an insult. I mean, we need to reach much higher. The US strategy, when we have one, and right now we have a negative strategy, so I'll stay with California. The California approach is the opposite. California does good analysis and then sets a goal that we think we cannot achieve because we only explore the full potential of technologies and policies by pushing them. It means that by definition, California will make some mistakes, but it will also reach for things that we think can't be done. And one of my kind of hypotheses for my work and this talk is that we need more of each. We need more of what China does well, setting goals and meeting them. But we also need more of what California does, setting goals that to some look impossible and then meeting them. California set the world's first standard for what fraction of homes should have solar. It was a goal for 1 million solar roofs in 2020. Most people thought it couldn't be done. California got it done early. Then California set a standard for electric vehicles, which by Chinese standards today will seem tiny. Back then, we wanted 1 million electric vehicles. This is back in 2015. We achieved that early. Now we've seen China become the world leader in electric vehicles. Norway has sold almost no gas-powered cars last month. These are goals that you need someone to set overly ambitious goals, and that's really how we've tried to work. So California's goal for 2030 was to be 60% powered by clean energy. Now we are 68 or 69% powered by clean energy. We have ended the importation of fossil fuels. No coal was stopped almost a decade ago. Now, every home built in California must generate as much energy as it consumes. And the thing I'm most proud of is the one that doesn't get enough attention. It's the one I hope we look back on and say, oh, that was really the innovative thing to do. California said 35% or more, it's a floor, not a ceiling, of the revenues from our carbon cap and trade market can be spent only on low-income communities or communities at the fence line of pollution or in minority-dominated communities. So it is what we call an investment in energy justice, or as is said in Beijing, inclusive growth. And just to note, in California, we do not count nuclear and we do not count large hydro as renewable. Now, that varies around the planet. In China, they're both renewable. In New York State, where I'm originally from, we count both nuclear and hydro as renewable. Germany doesn't count nuclear, but it does count hydro. Every place has a different mix, and this is California's perspective on this process. We're doing a number of new things. Right now, we have mandates for carbon removal. The one that I think is the most challenging and the most interesting, it might not become law, but right now, a very significant group of energy market economists in California is looking at a new way to price electricity. Not based on time of day or availability, but pricing carbon inversely proportional to income. The richer you are, the more you pay. The poorer you are, the less you pay. That is a brand new way to do power pricing, and it will be a battle. But again, reaching far ahead is part of what I believe is the most important here. The other part of the story is that in the global scene, Stanford and Berkeley usually battle it out for which one is the leader in the most new startups. For the past several years, Berkeley has been winning that competition. We're very proud of that. There are many leaders that do important things. And if we look at the universities that are the top leaders, there's a very nice list. Now we have Tsinghua and Beida as part of the top list. Johns Hopkins, which is very strong in medical work, is way down. One of my reasons to go was to try to make energy innovation a part of their landscape to bring that 54 up to 4. We shall see. So all of this is part of the story, but the thing that is most exciting, the new chancellor, Rich Lyons of Berkeley, very proud of a new book that's out. You can download it for free. It's called Startup University. And it is one of the facts is that Berkeley now leads by a huge margin as the university that creates the most companies with women CEOs. And so number of aspects of finding ways to diversify the process is part of what we work on. Now, I know that except for in a classroom lecture, you should never do algebra in public, but I just want to highlight one simple aspect of this model switch that I talked about. Not that we're going to do a lecture on power systems here, but just to highlight kind of the way that we think about a process that has led to this open source model used in more and more countries. So those of you who are technical, what we do is what should make sense. We minimize the net present value of all of the capital investments in the grid, new generation plants, upgrading transmission lines, the cost of energy efficiency policies. All of that gets put in. We meet the demand going forward, plus we keep some energy in reserve called the reserve margin. And that is as simple and straightforward a picture. As a physicist, that's the obvious way to do it. And all my computer scientist friends say, oh, this is very interesting. This is a problem that we need to work on because if you're going to solve for models for the energy future, this problem is very difficult to break down, or as they say in computer science, to parallelize the model, because the next step requires knowing what's at this step. So there's a whole interesting field of operations research about how do we use supercomputing, how do we use AI to solve problems when you cannot take the next step without knowing the states at one step before. So it has led to some interesting applied math that I absolutely will not get into here. But our modeling effort, again, these are the countries that we've worked with that have adopted the model. We have partners in country. We build versions going forward. And more or less what we produce are versions that I hope make sense. And just graphically for the non-electrical engineers, this is a picture of a carbon neutral solution for the 20 Western US states and the 3 Western Canadian provinces. The black line is one particular demand scenario. Light blue is wind. Yellow is solar. Dark blue is hydropower. Purple is nuclear. Red is geothermal. And the orange is energy going into storage. Sorry, I said it backwards. Orange is energy coming out of batteries, out of storage, and the orange is energy going into storage. And so the integral of the orange are equal. The energy going in equals energy going out minus the losses in the battery system. So it's quite a standard picture. This is just 2 days each month put side by side. We produce these scenarios. We talk through industry. We talk to utilities that often are not so thrilled about open access modeling because in the old days, they used to hold the keys to the kingdom. Utilities in most countries built their own models, and civil society groups, others couldn't see them. That world has changed. And so this is just one of the models that we use to do that kind of thing. And then to think hard about demand, but also about inclusive growth. We're increasingly using AI models. We map neighborhoods, we map industrial sites, we map infrastructure, we look at the energy demand, we use machine learning to identify solar on rooftops, we use machine learning and AI to identify thermal hotspots, demand issues, we do some computing, and we produce essentially demand scenarios in partnership with local governments. And then we solve the model and come up with, oh, this country might need more storage than this one because of longer rainy periods or more heat waves or whatever might drive these different scenarios. The other key part of the story that could be a whole lecture, but I'm just going to gloss over it, is the so-called Moore's Law. And that is what we observe is that equipment, not just energy equipment, but in this case, that's what we're interested in, is that energy equipment that can be mass produced has followed this dramatic decline in price. And for the engineers in the room, this is your best friend. This is a log-log graph of the price of energy from this technology, not versus time, versus total amount deployed. Time is just a stamp along the curve. And when you see a straight line in log-log space, that's a power law. Very, pun intended, powerful piece of analysis because it means we can predict future prices just based on that rate of decline. The slope of the line shows you the rate of innovation. What this says for solar, for the past 5 decades, with a few little wiggles, the price of solar has dropped by the slope of that line by 20% every time you double the amount that can be deployed, which means that aggressive or clever governments or cities can forecast the price decline based on the global increase in deployment. It holds for solar, it holds for batteries, it holds for many technologies. There are some very interesting exceptions. This is a paper we published over the summer in Nature, looking at the price of nuclear in a variety of countries, for example. And I throw this up because it has just some interesting lessons. What you see is the price of nuclear in the United States has been rising dramatically. For a long time, we thought that the price of nuclear in France was actually quite different. But this is France in dark blue. This is US in light blue. The latest nuclear plants in France are essentially as expensive as we're seeing in the US. Whether there's a new renaissance of building small modular reactors or others, we'll see. But the dramatic difference is what we see for South Korea in green and China in red, where the prices are slightly ticking up, but they're dramatically less. Now, there are many PhD theses buried in this graph. On the one hand, it looks like a dramatic difference. But on the other hand, nuclear power plants have a mixture of old and older plants in the US and old and somewhat newer plants in France, and generally nuclear plants in South Korea and here in China are much newer. Are we seeing a fundamental difference in design and safety, or are we simply seeing a difference based on older plants require more uptake and maintenance and refurbishing? We don't know yet. But this is the best we can do with available data now. And I kind of leave it to some of the students to think about. Maybe we can find a way to dig in to this in detail. One critical feature of high interest in China is if we look at the evolution of nuclear in China, the early nuclear plants here used a large amount of international parts and materials. Now China's nuclear industry is almost entirely indigenous, and we've seen dramatic price declines going along with that. So there's lots of really interesting work to do, mixing AI, machine learning, and energy systems analysis in the nuclear area, if that's of interest. This is the same curve for energy storage. Almost everyone in the room is holding a device in your pocket, which is the blue triangles. This is lithium-ion batteries. There are liquid flow batteries on here. Lead acid car batteries are in yellow. We don't see much learning there. It's a separate topic. And then pumped hydro in green. And there's a reason why those two technologies do not show the same amount of learning the others do. So lots of interesting data science applications to think about where we're going. Where this has played a critical role in California is that while the solar resource is good, if we look at the energy demand from midnight to midnight in California, you can see we had significant imports, we had gas, we had wind, we had a lot of solar. What's happened in only 3 years because of the price declines of solar, but in particular from storage, is you can see the wings on this curve here have dramatically increased. We are making intermittent renewables, solar and wind, more and more baseload by having more and more storage. We need longer duration storage than we have now. You all know that your battery in your cell phone is frustratingly quick to discharge, which means it gives you about 4 hours. And in many places with storms, with bad weather, we need storage that lasts days or weeks. That's an area where we do not have good technologies yet. We will need to keep innovating. Back to the large scale, as we think about using these models in different ways, one of the opportunities or one of the moments in time that if the US had chosen better in the last presidential election, we would be on this path, is that President Biden and President Xi signed the Sunnylands Agreement in 2013, the APEC summit in San Francisco. And of course, the APEC summit this year will be in Shenzhen. So I am looking forward to attending and hopefully making some interesting announcements along the lines we're talking about in a second. But you can see the Sunnylands Agreement was one that said China and the US should each triple the amount of renewable energy they are using by 2030, and they should work internationally in partnership, whether you want to call it the Green Belt and Road or international aid programs, to help other countries build similar amounts. The growth rate of clean energy is dramatic. This is an exponential rise, China being the biggest single player in here. But you'll notice that the amount we will miss our target by in 2030, this bar here, is equal just about to the global amount of installed clean energy in the year 2023. So we are very far from a target that looked entirely achievable, hence the signing of the Sunnylands Agreement in 2023. So we have a great deal of work to do. Okay, kind of moving forward, I want to highlight something that often comes up at this point in a talk like this. People say, well, we've already seen a great decline in the price of solar. We've seen a great decline in the price of batteries. This Moore's law will eventually end. And I think that's actually not true. We are seeing dramatic new innovations every day in countries that continue to invest in research. I just visited companies in France that are now making transparent solar thin film so that the windows in this room could let in just as much light as they do now, but also generate solar. That's one interesting area of innovation. Another area is that we are seeing a huge build out of offshore wind in China, in the UK, in Ireland, in a number of places, not the US, we'll leave that aside. But one of the interesting features is how can you take more advantage of the same offshore infrastructure? So this is an innovative technology. This particular one comes from a partnership between Norway, KTH in Sweden, and the government of Portugal, to notice that if we look at solar and wind, they are on this graph here, but what can we add to that system that would give us more use of that infrastructure? Well, wave and tidal energy is almost entirely unexplored. There's a nice research center in the Orkney Islands in the UK. And here is a technology that is now being deployed for the first time at commercial scale. Some of you may have seen it, but I'm willing to bet most have not. This is a buoy. This is in a storm setting here. I know it gets a little seasick, but this is a buoy. Inside it is a device that's being tested here at the laboratory at KTH in Stockholm. And this is a buoy, a 20-meter tall buoy. Inside is a piston. And as the waves go, this goes up and down, generates energy. And a system like this can be integrated into the same transmission lines that bring power in from wind turbines. So you can essentially have a dual use of the infrastructure to get more power out. In fact, the claim of this company called Core Power is that they can get more energy out of the strings of these buoys than from the above water wind turbines, so that a mixture of them more than doubles the output. And so very interesting opportunities. When I gave this talk 2 days ago, I then got a call that night from a company that says, well, you highlighted this Swedish company. Why didn't you highlight this new San Diego company doing a similar design with more of a spherical ball? So there are exciting new opportunities, and I'll come to my favorite and probably most controversial at the very, very end of the talk. So all of these are opportunities to look at innovation energy systems, to think about how we can integrate it into the landscape. How can we take more advantage of the resources in coastal communities? How can we invest in communities so there's more justice involved in who gets the jobs in the energy area? Recent studies in Japan where we found that even without nuclear, and Japan is, of course, still debating what to do with its nuclear profile after Fukushima. But what we found is that with an intensive investment in offshore wind around Hokkaido, Japan could be an entirely clean energy country. They would likely need not only to do offshore wind, but also to do a mixture of electricity and hydrogen. Some people believe in hydrogen, some do not. And then a recent study I'll highlight a little bit more in Kenya. The red is geothermal power. And Kenya is one of the global leaders in geothermal energy. And we'll come back to that in a second. I won't go into the story because I'm starting to get the first signs we need to wrap up. But one of the interesting areas that everyone involved in the energy debate has looked at is something called the duck curve. And this artist has replaced the duck with a dinosaur, which may be appropriate. And the basic story that I won't get into is that same curve of energy demand from midnight to midnight. And as we install more and more solar, this is for California, what you see is the net demand has been hollowed out, which is the back of the duck. To an energy scientist, that's the best news possible. We're bringing the net demand down to zero by installing more and more solar. To many of my economist friends running utilities, this is a horrible story or a partially horrible story because what it means is that the marginal value of adding more solar, for example, goes down. Well, that's an old world. Now we know the rise of electric vehicles. We could be charging up our vehicles the traditional way, grid to vehicle, but we could also be requiring, for example, that every electric vehicle manufactured and sold must be available to do something called V to G. Not only grid to vehicle, but vehicle back to grid. And if we do that, we suddenly have discovered a massive fleet of mobile batteries. Most of our electric vehicle batteries could power a home for several days. So now we have a way to have dual use of those batteries, very much like people are doing Airbnb, where you use your residence in multiple ways. So there's opportunities, and of course, if you believe in green hydrogen, you could be adding value to the solar there by generating green, not gray or some other flavor of hydrogen, but green hydrogen. All these are opportunities to think quite differently. And we're seeing this taking a huge effect. What's plotted here for energy market enthusiasts is in California, charging up batteries when the prices of power goes low and discharging late in the evening when the demand is high, finding ways to use clean energy storage for arbitrage. All of these are exciting opportunities coming our way. And one of the leading efforts of this is not only what has happened in Shenzhen with now the rise of the world's largest EV company, but also others trying to jump into the market too. We know, of course, and you've all seen, there are so many electric vehicle companies here. Here is the leading Vietnamese version. They've donated some cars to our laboratory in Johns Hopkins. This is the company VinFast. They've donated a VF8 and a VF9 that we're working on the very low-cost electronics to do this vehicle to grid. These are opportunities to build things differently. I'll skip that in the interest of time. But one of our early projects, which sounds quaint and small today, but 10 years ago was cutting edge, was the city of Shenzhen said they wanted to replace all gas-powered taxis with the blue and white ones you see in Shenzhen today. So we worked on the logistics side of that, and the city did that. Of course, BYD, a hometown company, they used their vehicles. They replaced the taxis in 1 year. They replaced 95% of the taxis. That was over 20,000 taxis. Again, small numbers today. China has about 30 million EVs, and over half the sales of new cars now are EVs, but that wasn't the case 10 years ago. And what you see is a map of the waiting times to recharge your electric vehicles at the Shenzhen Central train station and elsewhere. So we worked with them, and as we saw the long times required to queue up to recharge, I and my colleague Qinghua said, well, we should write a research grant. We should write it, submit it to the government. Maybe we win the grant, maybe we don't. In 6 months, we'll have the money, we'll start my study. And our students said, you two are really so 18th century. You don't need to do that. All you need to do is tell us to do it, and we will do what students do. we'll build an app. 2 weeks later, we had an app that developed a game for taxi drivers. And the game was, if you arrive exactly at your scheduled moment to recharge, you get bonus points. And if you arrive late, you get penalty points. And almost overnight, we had a 20% reduction in the wait times. And this has been expanded further. My student, Andy Zhang, who launched the company Pear City, based in Shenzhen. Now they do very integrated, this is for Chengdu, very integrated kind of smart solutions, integrating electric vehicles, taxis, e-bikes, the trains, to do similar at the scale of very large cities. So we can learn, and we can in particular learn from our students that don't go through the traditional process. Jump on an app, make this happen. Okay, let me conclude with something else. I'm not going to get into this talk, just in the interest of time, to the issues around the critical materials debate, where obviously the US and China are having a slight debate today. But what I want to end with is a story around innovation, and that is in looking at the challenges around one particular material, cobalt, where today the Democratic Republic of Congo is the source of 70% of the world's cobalt. Much of that cobalt comes from areas of environmental and political conflict. Child labor is involved. There's a number of challenges. And one of the solutions came quite easily. Research in material science using AI identified an alternative to the lithium ion in our phones that involves cobalt, and instead involves lithium phosphate, much more common materials. Already several EV companies, including Tesla and Volkswagen, have switched entirely to this battery with almost the same performance as lithium ion, without this conflict materials involved. And so just kind of highlighting this kind of story. My last kind of comment is the one I said I would conclude on, and that is this whole process and strategy has led us to thinking about how can we electrify health clinics around the world using clean energy systems. We have a program that was run by USAID until the current US president canceled all of USAID, essentially to design smart systems, to use batteries, advanced batteries, solar panels, and IT systems to make more and more remote health clinics not only run with sustainable power, but also so that they can generate power as mini grids and sell it or provide it to the local neighborhoods. This was going quite successfully. We have a nice global team doing it. This is the largest mini grid in Africa. It's in the city of Goma in DRC. And you can see for the electrical engineers, the huge variations in the voltage before we installed such a system, and large voltage fluctuations cause breakdowns of baby warmers, of refrigerators. I won't do the details here, but afterwards you can see how steady and calm the power is, and extending the lifetime of medical equipment dramatically. Okay, all of that brings us to my kind of last point. We're talking about using advanced drones to deliver medicines to these clinics to take advantage. This is Xiping in Shenzhen, looking at some of the opportunities for drones and other delivery equipments. And what I'm going to end with, because I know I'm right at time, is I'll skip the fusion story and make a joke at the end, is this opportunity to collaborate. So the reason I moved from Berkeley to Hopkins is because Michael Bloomberg, I think I jumped ahead too quick here. Oops. Sorry about that. There we go. Michael Bloomberg has made an unprecedented commitment to Johns Hopkins to address global challenges, and that was what lured me east. He has been investing billions in all kinds of different innovative programs, and so one of the things that I'm hopeful, if we can generate enough partners, is to take advantage of the fact that this investment over time has a chance to leverage something that Johns Hopkins has already done. In 1955, Johns Hopkins opened its campus in Bologna, Italy, a very successful, called SAIS, School of Advanced International Studies Europe. And in 1985, opening the campus in Nanjing, China, And so what I have been working with a team to build out and propose is that Johns Hopkins should open its campus in Africa. Many of the fastest growing economies on the planet are in Africa. In fact, 13 of the fastest 20 growing economies in the world are there. So the idea is to found a research university on the Kenyan coast that would do several things. The faculty would be organized not in traditional departments, but in the ways that we have found survey after survey of students in the US, in China, in Africa have asked for, and that is faculties designed around engaged themes to address key challenges. In the African context, energy and energy sustainability is a critical issue. Kenya is 94% powered by clean energy because of its exceptional wind and geothermal as a host for such a university. So one theme around energy systems, a second theme around the marine economy, which I've highlighted in the talk a little bit, and the third theme around land use, gender, and biodiversity, which are linked topics on the African landscape in multiple ways. And the thing that has generated a great deal of interest in doing this overall is not just the opportunity for such an engagement as Hopkins has already done, but also an effort to raise money from corporations, from individuals. So not only we have this university, but students from Europe, from the US would go and pay whatever the tuition is, but African students who attend would attend on full scholarships. There's a whole variety of new technologies. We're already seeing partnerships with companies in China, in Vietnam, and the US to do all kinds of new ways to do marine exploration, a whole variety of different topics. And I'm hoping that those of you who have taken down the links that I've highlighted before to our laboratory will reach out if you're interested in the research side, the funding side, the partnership side, to take advantage of the innovation that certainly was going on dramatically in the US. We'll see how it survives the current regime, that is going on in China, and the huge opportunities for that kind of work in Africa. So thank you for letting me go just a slight bit over. I hope that gave both a flavor of the research in the lab we're doing, but also the opportunities to apply that in some really new ways to the educational model worldwide. Thank you all for your attention, and I look forward to the discussion. Hopefully we'll have a bit of it right now. Thank you so much.
Good afternoon, everyone. My name is Ye Guo. I'm a new faculty member at the Department of BEE, and it's my great honor to moderate this Q&A session. And thank you so much, Dan, for your enlightening talk. I think the theme, just energy transition, as well as the encouraging scenarios, the challenges are really impressive to me. And without further ado, may I invite questions from the audience?
Very thankful for your wonderful speech, Professor. And I now want to ask the huge power consumption of the frequent usage of AI tools. I once learned in the internet that one 5-second video produced by Sora, the energy consumed could burn like 7 or 8 tons of water into water vapors. So I think that with the AI is more and more frequently used, maybe it will also expand a large of proliferation of the energy consumptions. Have you ever?
Great question. So this is one question that I'm hoping will essentially solve itself. And whether you think AI is for good or not, we don't fully know yet. There are a range of views, but it's clear that many people on the planet in both rich and poor countries need more energy and need more affordable energy. So instead of seeing the rise of data centers as an energy problem, I think it's really a social question. Do we use it for good? Do we create more jobs or get rid of jobs? But I think the real interesting opportunity here is, I'm a physicist, not a business person, but it's very clear that the idea that somehow added demand for energy is the enemy is, I think, entirely misguided. We want us to use more energy, but we want us to use more sustainable energy. So a very simple policy intervention would leverage that. And that is, I'm not against data centers, but I think that every data center investor should be required to, as they say, bring their own generation. Maybe not all of it, but a simple rule that if you want to build a data center, you are required to also construct a power plant with renewable energy that meets a certain fraction. Different parts of the world might set it differently. In California, we would almost certainly say a data center must generate at least 100% of its needs. And if it generates more, it can sell that power and have a second revenue stream. Some other places may say 50%. But the idea that you would just let a data center come online and not have to also provide new generation seems like a loophole in energy planning. So I think it's a great question, but I think the solution for this one is very straightforward. Simply require, you want a license, you get into the generation business, which 20 years ago was difficult. Now getting in the generation business with solar or wind or geothermal or in places that permit it nuclear, this is straightforward.
Thank you.
Yeah, thanks, Professor. Thanks for your really nice talk. And in your slides, you mentioned the dark curve. Up to now, the dark curve have intensified into chemical in California up to now, as I understand. So some researchers claim that constructing more energy storage may be a potential solution. So how do you think about that?
So I agree. I mean, I showed the graph. I showed that California from 2021 to 2023 increased the amount of storage dramatically. California no longer offers a subsidy for installing solar, but if you install storage, you can get a subsidy. And most people or companies that install storage also do solar. So you get solar for free or for low cost. So I think actually the rise of storage, Texas is now scheduled to install more storage than California has. China is a global leader. In Finland, they're now installing batteries made of sand because sand stores a lot of heat. We have gravity storage where you move blocks uphill. And so I think there's many, many ways to make storage the glue of the new energy system. So I think that after the one thing I didn't mention, and that was what I think will be the next big innovation. I think the innovation we're in right now is the rise of storage. I think the next big innovation will be, and this is the somewhat grand prediction, I actually think that by 2070, the world may be 70% powered by fusion. Now, let me qualify that. I think half of that fusion will be something we do not have today. That is fusion power here on the surface of the Earth. But I think the other half of that will be solar. Solar is fusion. It's just 150 million kilometers away, the sun. So I think 2070, 70%. And to say we'll get to 35%, half of that, from terrestrial fusion, which is zero today, with only one site that's doing fusion. That's the Livermore Laboratory in California. But we have about 60 fusion companies, some of which are very promising. I would predict that of those 60, perhaps 10% become active fusion companies. K-Star in South Korea, very promising. The fusion here, the ITER reactor that will be coming online in Europe, and then many, many small fusion companies. I predict that we will see fusion plants on the grid as trial plants, pilots, within a little more than a decade. So I think that will be the second big innovation, but storage is the innovation we're in today.
Thank you. Any other questions? Yeah.
Thank you very much, Dan, for the wonderful talk. And you cover very comprehensive, scope of the electrified society. I think which is I think it's great, and to see the future in the next couple of decades. But if you look at, so practically, if we really want to achieve carbon neutrality, only electrified society may not be able to do that. So you touch base a little bit on the hydrogen. Right. And if you look at our Mother Nature is doing basically, photosynthesis is a chemical energy storage.
Yeah.
What's your perspective on the other part, like the current giant, like petroleum industry and the other fossil fuel-based one? They use chemical energy. Yeah. And if we want to do in a sustainable way, what's your perspective on the chemical energy contribution?
So I great question. I guess I would add to that, and that is there's a whole sector that we call hard to decarbonize. Heavy industry needing a lot of heat. These are things for which we have not done enough work. Aviation remains a big challenge. So there are huge areas, and it's why the U.S. turning away from research and development is so saddening to me, because the U.S. has been such an important driver of R&D, research and development, since World War II. And now we seem to be doing something that I can only compare to a patient deciding to go on a diet by cutting out a few ounces of brain matter. And it doesn't make sense. So there are difficult areas. We need research. We need to get research more quickly into the market. We need the kind of startup innovation culture that I described before. And I think that one of the issues is, you're right, the chemical storage has served us very well. I'm not at all against hydrocarbons. I just don't think we should burn them. I think there are many products, plastics, cosmetics, many things for which we need that. Energy storage, those are great areas. But the thermodynamics of burning fuels means you throw away 70% or more of the energy because of Carnot's law, second law of thermodynamics, unless you're incredibly good at capturing the heat. And only a few places have really tried hard. In Eastern Europe, they use waste heat to heat neighborhoods. So there are some things we can do. But the idea that we would go forward on a planet already with 8 billion people, with limited land, with limited atmosphere, and think we're going to throw away 70% of the energy through combustion makes no sense. Electrochemistry. We can do high temperature solid oxide fuel cells. We can do hydrogen if you believe it. I am personally a skeptic, but I want us to see which ones win out. And I'm very optimistic that by solving the easier to solve areas, and remember, 30 years ago, no one thought that solving vehicles was going to be easy. Everyone said this is so hard, we're going to fight and fight and fight, and maybe it's diesel, maybe it's that. Now, everyone under 30 in this room, I doubt you'll ever own a gas-powered car. There's no reason to. It just doesn't make any economic or environmental sense. Kenya is a global leader in the number of electric vehicle companies, from four-wheelers to battery swapping for two-wheelers, kind of doing what NIO is doing in China for battery swapping for cars. There's lots of opportunities. And so in my view, solving the immediate problems opens the door to solving the harder ones. And you're right, we have some serious issues around the materials we need. We'll need hydrocarbons. I just don't think we should burn any of them.
Thank you. Are there any other questions?
Hi, Professor. I'm Xiao Shiting from HKU, and I have been. So first, thank you for your fabulous speech. And I have been trying to build the energy system modeling tools by myself. And I learned a lot of from your pioneer modeling tools like Switch and Switch China and etc. And the question I want to ask is, I've been trying to study the cross-border electricity trade, the role of electricity trade in promoting the carbon decarbonization. And I want to ask, what is your view on the on how should we promote as much as possible to build cross-border transmission lines to promote the electricity trade to decarbonize, or is there a limit, and how can we assess the limit of the
Yeah.
cross-border electricity trade? Thank you.
So this is, I think, one of the frontier areas of research. For a long time, energy modeling took place within individual utilities with limited trading between them. Now we're seeing with not only better modeling tools so we can share data, but also more interactive, so they call it switch gears, so that one area can sell power to another. Here in Hong Kong, a significant amount of energy, in particular nuclear, comes from China. Where I am in California, where I was in California, we have a very interesting relationship with the Pacific Northwest, with Washington State and British Columbia, where we need their hydropower in the summer and they need some of our energy in the winter because of the strong cloud. So there's real opportunities for trading. It's not always easy. In Kenya, in East Africa, which is part of so-called the East African Power Pool, both Kenya and Ethiopia want to be the dominant exporter. Kenya wants to export geothermal power to Ethiopia. Ethiopia wants to send hydropower to Kenya. And that's a situation where just energy modeling isn't enough. Each one wants to be the dominant actor. But ultimately, someone has to buy and someone has to sell. So there's an opportunity where some politics is involved to find a partnership so each country can feel they're doing well and find a way to work together. But larger and larger power pools, cross-border, cross-regional, generate all kinds of opportunities. Europe could not be on the pathway as quickly to decarbonize as it is today without Norway being the green battery and sending hydropower to Europe as an opportunity. So there are some natural alliances that allow different arrangements to go on to essentially replace those natural gas and coal and other pipelines. But it doesn't take just the kind of energy modeling that kind of you and I do. It also takes some political dialogue, of which I'm not as good at. And so I do think this is an interesting area where the pair series, interdisciplinary, it's not just about the STEM models, it's also about the geopolitics. How do countries feel secure so that a neighbor doesn't cut off energy? So all of these are part of the story, but as we get more and more interconnected, we even get to the point, there was a recent paper proposed by researchers at MIT and Tsinghua, and that is China and the US should partner with long distance power trading, because when it's daytime in one, it's nighttime in the other. And so we can send solar power to you and you can send solar power to us, and we can find a way to take advantage of those resources. The technical story is doable, but the politics right now are a little bit messy.
Yeah.
So this is the kind of world we could get into, but we need to do something that we will ultimately have to have on a hot, crowded planet, and that is trust. And right now, trust is in short supply.
Okay, thank you.
Thank you. Are there any other questions?
So I have a small question for the Johns Hopkins African program. So will it be a program to help the global South countries to build a new standard about the sustainable investor to invest their powers instead of the ESG, like investing standard from the more developed country to maintain their social and biodiversity? Yes.
Yeah, so it's a great question. And so one of the reasons why I'm so excited about this opportunity is that every time a technology leader invests in sub-Saharan Africa, we see dramatic gains. IBM opened IBM Africa over a decade ago in Kenya, and it's been one of their most productive centers around the planet per employee. More patents, more innovations coming out of that Nairobi center than essentially any of the other IBM offices. I think the same could be true in many areas. BYD has a major sales office in Kenya. number of African countries. I would like to see a whole range of partners investing around these locally important issues. And that's why the three initial areas chosen for this university, energy, the blue economy, and land use, gender, biodiversity is kind of one topic, all have significant local need and opportunity, but also leverage incredible local talent. And when we look at the spread of many universities, China is famous for universities that open branch offices elsewhere. The US has been slower to do so. A number of European universities have. I believe that Johns Hopkins, with its record of doing this quite successfully in Nanjing and in Italy, the natural next place would be East Africa. So I'm excited about the ways to invest in indigenous issues, hiring local African faculty, supporting local students, fellowship programs so that African students would go for free has been one of the things that's really generated a lot of interest, not only in Africa, of course, but also around the world. That's something that many governments and companies and individuals have said, I would like to provide endowment money to support exactly that. I would like to see this undertapped African potential supported in this effort. So thanks for asking. Yeah.
Thank you. More questions are welcome. Yeah.
Hi, thank you for your wonderful speech, Professor Kammen. I couldn't help but notice the word you mentioned in your slide is energy justice. So I'm curious about what's your understanding of this term and what's the challenges to achieve it?
Yeah.
Thank you.
So great question. So of course the language varies, right? What we call in the U.S. energy justice is more generally called inclusive growth here in China. And so one of the features is, how do we build energy systems that promote inclusiveness and promote equity? In many parts of the world, especially where there's low access to energy, you also see low access to refrigeration, higher food costs, low access to education. There's many places in the world where children need to go and sit by a cafe so they can use the free Wi-Fi. These are not good for families and education. And so finding opportunities like in this effort to invest in electricity at health clinics. Everyone needs health clinics. They're generally quite widely spread, but in many parts of the world, and I highlighted sub-Saharan Africa, where many of them don't have reliable electricity. These are ways to make clean energy a tool for inclusive growth or justice, and not just build clean energy for the rich. And in fact, the statement that I think is maybe most accurate and worries me the most, especially when one travels around a place like Shenzhen, is you see there's a famous quote from the futurist William Gibson, who said, the future is already here. It's just not evenly distributed. And when I go to the world's largest and fastest growing drone delivery operation in Shenzhen that sends 20,000 packages a day, something we do not have in the US and is almost entirely absent in Africa. But when I was in Singapore recently, at the rooftop restaurant bar and the famous the ship restaurant on the top, I ordered a beer using a QR code, and the beer arrived on a drone. I took it off and then went back. And that's the kind of cute use, but this package delivery, delivering blood supplies, delivering critical materials, bringing food from market and hilltop communities, these are all opportunities that we can use clean energy to make the world a more equitable place while also doing a good business. I think these are not incompatible, but we typically don't do it that way. So that's what I mean by energy justice or inclusive growth. So thank you for asking.
Thank you. And I also have some text form questions. I think we don't have enough time to go through all of them. Maybe I think the first two are somewhat related. So they asked, are humans ready to face the new challenges brought by the new energy sector? How to better balance carbon emissions and energy production? I think mainly there are in some rapidly growing economies, there may be skyrocketing demand of energy. is constructing renewable energy the best and the most affordable option for them? Yeah.
So this is one, again, that I think that energy innovation solves itself. And that is, if you look at the benefits of installing clean energy versus gas or coal, per unit energy, you get more jobs at lower cost from clean energy than dirty energy. And in fact, 80% of all new energy installations around the world last year were clean energy. So why isn't this story solved? Well, it's not solved because some places, China is one of them, are installing a great deal of clean energy, but also have plans for many more coal-fired power plants, despite what I just said. So that means the story is more complicated. And it's complicated in a number of ways, but one very clear one is that right now, in both the United States and China, just to take two examples, even if we converted overnight to clean energy, which I think no one believes will happen, it would have significant jobs issues. In China, some of the estimates are if China were to close its coal mine and coal industry, that could be between 500,000 and 1 million lost jobs, because the clean energy jobs are largely on the coast and the coal is largely in the interior. It's the exact same story in the United States. If we were to close our remaining coal mines, and our coal industry is much, much smaller than yours, it would result in lost jobs in some poor, conservative, or what we call red states that voted for the current president. So that's not a fault of clean energy. That's a fault of our employment and industrial policy. And I don't mean this as a criticism. That's a fault in China, and that's a fault in the United States. We should be bringing those clean energy jobs to the communities that are going to lose the most. Now, that's not easy. People want to move to San Francisco and Shanghai, and they're more reluctant to move to, I won't mention the cities in either country, that are not as attractive for young people to move to. So we're going to have to be more just or more inclusive and find ways to get those companies to move to this area. So I was in Tianjin recently, and an industrialist there said because of this, he decided to convert his entire delivery fleet of 3,000 vehicles to run by either electric or hydrogen. And he wants to bring jobs to Tianjin, working with the university. That's an example of inclusive growth to bring jobs to the areas that are most at risk to lose it. The same thing is true in the US states of West Virginia and Wyoming that are fossil fuel-based states. We can't expect the market itself to simply place all the jobs right where we lose the most. We have to invest. And so I think that's what governments are for. So we should find ways to do that. Institutes of technology, polytechnics, located in those areas are a great way to build out that capacity. And it's one of the reasons why I'm so excited about this effort to hopefully build Johns Hopkins in this underinvested in part of the Kenyan coast. It's an example, but it's a small example of doing that kind of investment. Not easy. Politics and economics sometimes align, but sometimes don't.
Thank you, Professor Kammen. And because the time is close, I think the third question is probably quite good as a concluding question of today's seminar. He asked, I wonder if young scholars have chances to make any contributions to the current urgent situation, both from the perspective of academy and also practice. There are many young scholars today, so perhaps you'll have some response to this. Yeah.
So that's a whole talk, right? But I think one version of that is that if you look at the climate emergency movement, the Greta Thunbergs in Sweden, the Vanessa Kate in Uganda, the Alexandra Villaseñors, the youth climate leaders are asking for a place at the table. And unfortunately, my generation is not very good at being inclusive. My generation seems to be really good at hoarding resources and hoarding power. So finding ways to share with the emerging generation is a critical part of the story. And I have many examples I could highlight. I mean, certainly the clean tech entrepreneurs are generally young, but I'll say a quick example story from Morocco. 10 years ago, Morocco decided they were going to become a clean energy exporter to meet the rising demand for clean energy in Europe. And they thought a transmission line would be built under the Mediterranean to connect them to Spain. Well, it turns out Spain was having its own economic problems, even though Spain's a huge clean energy leader. So Morocco said, "It's okay, we'll invest in wind and solar." And for a long time, Morocco had the world's largest battery. But what they did at the same time was the most interesting thing. Morocco said every national university will have to open a new department of energy engineering. And lo and behold, they did that. And what they found is that those new departments were the most in demand, but in particular, they were the most in demand for underrepresented engineers, women and minorities, in particular Berbers. And I don't think it's any mystery. If you open up a traditional department, I won't pick on anyone in particular, electrical engineering. Electrical engineering is typically, in much of the world, male-dominated. Open up a new area of research, a new area of instruction, and just because it opens a new window, it actually often generates a more diverse mixture. Now, you can do more to do so, but what Morocco found is they now export energy engineers to Europe and to the rest of Africa. And in particular, they are the most diverse engineering department across their whole schools of engineering across the country. So whether that was luck or by design, that was an incredibly clever and inclusive move. And I think that we need to lean in much more to lessons like that, to make the academy, to make in particular engineering and business more friendly to underrepresented groups. And I don't think it's that hard. I just don't think that we're not good at it. And my generation has proven it has been a real impediment to that kind of progress.
Thank you so much, Professor Kammen. And I think this shall we conclude this Q&A session?
Thank you so much.
Thank you so
Appreciate
much.
it. Thank you.
Thank you.
Thank you all for listening for so long.
So thank you again for your wonderful talk, very inspiring. We learned quite a lot. To express our appreciation to you, we make this a special plaque with your name and the title of presentation. I also wanted to invite Professor Lee, Professor Guo, and then also Jerry, also Professor Zhang, maybe together to take a photo here. Yeah. All right, I'd like to thank all the people here today for your participation, especially for those who ask questions. So I really appreciate that. You probably know that the pair organize distinguished lectures from time to time. Our next lecture will be after the Chinese New Year, will be given by Professor Fikram Dispente from the University of Cambridge, who is a scientist in materials. So please keep tuned on our announcement. Thank you very much. This lecture is adjourned. Thank you.